Okay, so I'm going to talk today about industrial Internet of Things, or industrial IoT. A lot of this is coming from my personal experiences, having recently been on a project where we've started to do a lot of this industrial connectivity and dealing with telemetry. So my name's Kent Weare. I'm a Microsoft MVP, and I work for a multinational power generation company in Calgary, Alberta, Canada. In addition to those other activities, I'm also an author, and I'm an editor on Richard Seroter's InfoQ Cloud editorial team. I'm also a blogger when I have chances as well. So today what I wanted to talk about was an introduction to Internet of Things. I wanted to talk about our journey within our project. I want to go through our reference architecture and how we see the different building blocks in Azure in order to deliver solutions. And then I do have some demos. So I do have a lot of content. I'm going to move through it relatively quickly, but I'm more than happy to dive deeper after my session. So first off, what this talk is not about. It's not about a dancing robot hooked up to a conference Wi-Fi network being manipulated by an iPad app. This is really what we're talking about. So these are power plants, nothing specific around the fuel type, but at the company I work for, we have a multitude of different fuel types: gas, coal, wind, hydro, and solar. So what is industrial IoT? Really, the way I look at it, it's devices connected through communication software that can be monitored. The data can be collected, exchanged, analyzed, and instantly be acted upon. Industrial IoT is not a new discipline. It's really the evolution of existing technologies. And for those of you who may not be familiar with these devices backwards, I have complete age envy over you right now. But really, industrial IoT, its roots are in SCADA. So SCADA stands for Supervisory Control and Data Acquisition. It's really found in industrial settings, whether that be power generation companies, pipelines, oil producers, car manufacturers, pretty much anything in that manufacturing space. And just to level set, because I would imagine not everyone's familiar with SCADA systems, here's just a high-level architecture that I was able to pull off the web, but I just wanted to explain so you can kind of compare and contrast with how we deal with things in the IoT space. But really what you have is redundant workstations, banks of workstations. You'll have redundant networks that are disconnected from your corporate LAN. Then you'll have application servers where SCADA engineers will build displays that actually can be run off of the workstations. We also have communication servers and data historians. And really this is going to be the focus of my talk today, is really in that historian space. So you can think of a historian as a large data store where calculations can be applied upon all of the different telemetry that's been received. And you can also do some trending. So even when we start to think about machine learning, that really isn't a new concept. Today, organizations have been using software that allows them to do predictive maintenance based upon historical telemetry data. Now, if we move down the stack, we're going to see a series of different devices that are involved in these sorts of plants or manufacturing settings. So I'm not really going to talk too much about that today. That's going to be covered in Mikel's session, where he's going to talk about how do you manage devices. But what you should know is that with all of these different devices, or IEDs, there's a vintage of protocols. Some of these protocols go back decades. This is not about HTTP and even AMQP. This is stuff that can be much older than that. But then there's generally some level of data consolidation, whether that be at an RTU or a PLC, a programmable logic controller. And at that point, you can start to aggregate or start to develop or use common protocols like the OPC UA that Clemens was talking about yesterday, so that you don't have complete disparity within all of your different devices. So the question is IoT and SCADA the same? And really, no, they're not. Their prescribed implementations are very different. On the SCADA side, there's a lot of concrete that has to be poured. You're developing infrastructure, you're provisioning infrastructure. Versus on the IoT side, a lot of it's software driven. So it's software defined networks, it's compute, it's large scale data ingestion, it's cloud messaging, and it is real-time analytics as well. So SCADA systems are highly dependent upon provisioning of infrastructure, multi-level networks, firewalls, expensive proprietary software or protocols, and generally an unwillingness to change. Now you can consider this, maybe it's for good reason, but some of these plants could be decades old, and going into a plant and saying, I'm going to change your life and I'm going to start doing all of this cloud stuff, you're probably going to get shown the door pretty quick, right? So there is this value proposition that you have to be able to demonstrate as you're going down this path. But if you are very committed to these systems, what you're going to end up doing is you're going to be burning a lot of cash. And a lot of it is really just the cloud economics of today. So for example, won't mention names, but there's a recent vendor we've been dealing with in this space that's trying to sign us up to a 6-year contract to use some of their software. Well, today I can go in Azure and pay by the minute, right? So why would I want to consider signing a 6-year deal, knowing that 6 years from now, this landscape is going to look very different than it does today. And even if you look back 6 years ago, we were talking about BizTalk 2010. And think about everything that's changed in Azure, in Microsoft, in integration in the last 6 years. So we would be crazy to go ahead and sign that sort of a deal. And for those organizations that don't adapt, I think this is what will happen to them. Obviously, people aren't going to start shutting down their plants and saying, oh, well, abandoning SCADA, very quickly. But the reality is, as other organizations start to adopt this technology, all of a sudden these other companies are going to have more and more challenging times when it comes to competing. And I think I've already seen this with some of the energy companies in Calgary, pipeline companies, where they may have pipelines that span hundreds and hundreds of kilometers, and it may not be it may not make sense from a cost perspective to actually roll the SCADA network over the entire span of the pipeline, or to collect as many tags as they like. And now they're starting to supplement that with some IoT solutions in order to reduce those costs and actually provide the business with more capabilities. So am I being too harsh? Am I dreaming here? I don't really think so. And I think BMW and their connected car plan is just an example of this. So if you had a chance to see the key, or one of the build keynotes that Scott Guthrie was involved in, BMW was on stage talking about their ambitious plans with the connected car. And it's more than just kind of social media and stuff like that, but it's, that's an example of how BMW is taking this technology, pushing the boundaries, and actually innovating and changing the way that customers will drive a car in the future. So I do have a link to this particular segment at the end of my presentation, so I'll be sure to share that with you at that time. So let's talk a little bit about our journey. What prompted our change in architecture? Why did we decide to go down this path of using Azure services in this particular domain? And really what prompted it was a time to upgrade. So within our organization, we have a partner who does a lot of our data collection and manages our SCADA network for a particular subset of our plants. They've been doing this for several years, and what happened was they needed to upgrade their historian. They use a different version of their historian than we do, different brand. And we had a few options. One option was, well, we could adopt their historian and do like a data sync, but then we would have this incompatibility between their historian and ours. It also would be a very significant price in terms of licensing that software, especially for a platform that wasn't considered to be one of our standards. Another option was they could enable a RESTful API in front of their historian, and we could go ahead and try to pull or basically call this REST API for all of our different tags. We weren't super anxious about that, knowing the amount of tags and the frequency of all of those RESTful calls that we'd have to make. So we had positioned using a cloud architecture really around Azure and Azure Event Hubs. And after some conversations, we were able to lock in on a solution. And when we looked at this, the core requirement was just about delivering delivering data. It was around data collection. Pick up data here, deliver it to point A from point A to point B. And really what we wanted to do is we wanted to deliver more. As an IT organization, obviously you're always trying to give your business more value for what they're paying. And we felt if we went down this Azure route, we could deliver on data collection and real-time analytics very quickly, and that's really what we've achieved in this iteration of the project. But in addition to that, we could actually provide more value in the areas of proactive alerts. So detecting when something doesn't happen but should have happened. Now we can easily do that in the cloud. We can add on those preemptive maintenance scenarios using machine learning as we go forward. And certainly we can start to do work order integration where we can now, if we detect some of these anomalies, start to log work orders, whether that be in ServiceNow or SAP, so that now we have people that know that there's a problem and can fix it right away, as opposed to looking at reactive reports or waiting for the business to say, hey, my data doesn't look right. Like, that's not a value-added service if you're finding out from your end users that something's broken. So this was some of the motivation why we chose to adopt this architecture. And another scenario was disaster recovery. So this is real. This is from 2013 in Calgary, where we had a 100-year flood. And unfortunately, this solution, the legacy solution, was down for several hours. I won't admit to more than that. But it was down longer than it should have been. And that created some challenges for both organizations as we tried to get this back online. And certainly recently, with a lot of the fires going on in Alberta, it was another reminder of how disaster recovery needs to be part of this solution. While we still have a ways to go, we saw this as an opportunity to outsource that to Microsoft. Now, not to say Microsoft's immune from natural disasters, but in terms of getting things back online, Microsoft is going to take care of that. If there was a disaster in one of the regions that we're in, Microsoft will be working hard to get that up, and that reduces some of the stress on us. We also, using cloud technology, back to that concrete slide, is now we can spin up these services in another region in minutes and basically be back online very quickly. So, can these two architectures coexist? This legacy SCADA and IoT. And I think that's what we've really tried to achieve, but it has been a balancing act. It's a balance between how do you kind of keep your legacy infrastructure, your legacy solutions, start to introduce change and introduce velocity. It's not feasible to go into a plant that may have thousands and thousands of tags and all of a sudden plug them into Azure IoT. You're not going to be able to do that. But what you need to do is find these common choke points where you can start to introduce this new technology that does provide advantages to the business. And that's really what we've done in this iteration of the project. So what did we implement? So a hybrid messaging platform that feeds our existing historian and allows plant operation personnel to monitor the state of devices and our power generation output, our megawatts. We also can provide telemetry for downstream reporting, compliance, and commercial purposes. So if you think about a power generation company, you're generally going to sign long-term contracts with other parties, and that's your commitment to generate power. But in the areas of, I guess it's all fuel types, if you have excess power capacity, now you can start to sell that on the open market. So when that happens, we can now feed that to our commercial team who's responsible for trading. So if the wind is blowing, if it's raining, the water's rising, if prices are high and we have the capacity to burn more coal, now we create this opportunity for the business. And if we can simplify that process and make it easier for those people that are working that side of the deal, then that's real money. That's real tangible money. In addition, we can provide real-time visibility to our field IT support. So these are the folks that are responsible for the data collection. If data is not being collected, they need to figure out why and work with the vendor or our partner to get that back online. And lastly, the flexibility to evolve. We don't have a static solution here. As we start to light up more and more Azure services, we can now plug them into our solution quite easily. So what were our timelines? So we started in January with initially a POC. It was kind of interesting where we were talking as an architecture team about using a cloud solution, and that leaked out to the business, and there were some concerns naturally, my data is going through the cloud. And that reached my boss, and then we had a chat, and I basically walked her through what we were planning on doing, what were the benefits, why we felt this was the good approach. And then I was able to demonstrate how this would work. And I think there was a lot of kind of fear, in general around the cloud, especially to people that may not be familiar with it. And what we were able to do is through a very quick POC demonstrate this technology, and then we were able to show the costs. And immediately we had buy-in from both the business and from IT senior leadership that, hey, this was the right solution because it allows us to scale, and we can pay for exactly what we need. We don't have to pay for peak. We can pay for what we need and adjust as required. So after some architectural reviews between both organizations, ourselves, our security teams, there was a contract that had to be signed. We got that sorted out. February, March, we started this build and testing. In April, we've done a parallel cutover. So right now we've got both systems actively processing reads. To date, we've processed 56 million device reads through this solution. Now, after watching Dan's presentation yesterday where he's talking about trillions, I do have a bit of an inferiority complex at this point, but the bottom line is this is real data, this is real systems. So it has been a good experience for us. And then this week, or actually next week, we'll be decommissioning the legacy solution and be completely reliant upon the cloud-based solution. So what was our reference architecture? Really, it's all around the Azure IoT services. So Event Hub, Service Bus, Stream Analytics, App Service, Power BI, BizTalk. And when we say App Service, in this case, we're talking about Logic Apps, and we're also talking about the Azure functions. I won't go through this in a lot of detail because I know some of this has been covered, but we are using Event Hubs for cloud scale telemetry ingestion. We are using the AMQP protocol as recommended by Dan and Clemens. We do have the configurable data retention, which has been nice, and it is pluggable into other services like Stream Analytics. Stream Analytics was new to us prior to this project, but it's an interesting technology. And I think the most kind of interesting part of it is this intelligent windows, which I'll get to on the next slide, but it really helps you in doing a lot of calculations. And really, when you think about field IT or plants, a lot of it is calculations because these devices can be emitting signals, milliseconds, every milliseconds. But you need to do some level of aggregation. You can't process that and send that all to your downstream systems. So we do calculations all day long in this kind of legacy software, but now Stream Analytics allows us to do this on the fly. So we can take advantage of things like tumbling windows, hopping windows, and sliding windows. And really, when it comes to these windows, in the case of tumbling, you can think of it as there's a fixed kind of window. And what we're interested in is basically the aggregation of data within that window. So in this particular scenario, and I'm showing the far left here, is we want to know the count of a particular sensor ID every 10 seconds. So every 10 seconds, it's almost like, oh, let's take a look back and see exactly what's there. And then the next 10 seconds, we'll do the same thing, and so forth. With the hopping window, it kind of looks across multiple windows. So what it'll say is every 5 seconds, I want you to look back 10 seconds. And now you can kind of see this blend between your previous window and your current window. And the last window is the sliding window, which is very deterministic upon certain conditions. So in this case, what it's saying is I want to know the min temperature for sensor IDs, but only once we've reached a min temperature that's greater than 75 for a 5-second period. So it's not basically a fixed window. It's waiting for something to be over 75, and then what it's going to do is look within a 5-second window for that. So this is extremely powerful. This is really the secret sauce of Stream Analytics, and this is what makes it extremely powerful. The alternative to this would be, let's collect a lot of data and then run a lot of these polling jobs to then go back and look at the data as opposed to doing it in real time. And the nice thing about Stream Analytics is it scales with Event Hubs. So basically, as you increase your ingestion on the Event Hub side, you can increase your scale units on the Stream Analytics side, and basically, it'll be able to keep up with Event Hubs. Service Bus Topics, we use it for pub-sub messaging. We also use it for messaging on our edge, which we've been using this for over a year in production on some other projects, and it's worked out really well for us, especially when we're starting to integrate with third parties that are outside of our network. It does offer load leveling for us. So in the event we have some downstream maintenance, we can let those messages queue up in our topic. And then basically when we need to let that data flow, we'll enable the BizTalk receive location, and we can now flow those messages down into our environment. Power BI, this is another pillar technology for us lately. It really has this hierarchy of data sets, kind of the raw data where you can now slice and dice, manipulate your data, reports where you're now starting to develop your visualizations, and then dashboards where you can now publish this and share it. And these can be real-time or scheduled updates, as Ashwin was talking about. It's generally a self-service data exploration and analytic tool, provides an office-like experience, and it's cloud and mobile friendly. So what we've really enjoyed about this is the ability to share. Now that's obviously a double-edged sword, but when you can now go to your boss and at a click of the mouse share a dashboard and they see it on their phone, without having to install anything or go through some onboarding process, it's pretty mind-blowing when you see the velocity in terms of what you can do with some of this stuff. So BizTalk Server, it continues to be a pillar in our reference architectures. We're using it primarily for our on-premise integration needs. We're doing some protocol mediation, data format transformation, and certainly routing. In the areas of logic apps, we see this as our cloud-based orchestration. And one of the use cases I like is the SaaS connectivity. We'll see some of that changing with BizTalk Server 2016 and its ability to integrate with logic apps and take advantage of some of those other connectors. But in the case of ServiceNow, where I'm going to show you in a demo, I like doing that in logic apps and API apps because I can do that much quicker than I can do it on-prem with BizTalk, and I can certainly take advantage of some of the connectors in the areas of notifications, such as email, SMS, and we saw Slack and Yammer as well. But for our context, SMS and email are kind of our targets where we can quickly wire that up. And we can use that basically almost as an off-ramp as we start to understand some of these exception processes. Let's spin that off into a logic app where we can start to use some connectivity and develop some solutions very quickly. So the first demo is, just to set some context here. So each of these demos layers on top of one another. It's kind of a mix between what's in our production environment today, plus what are some of our future opportunities. Now, I can't show you our exact production data, probably that'd be frowned upon. So what I've done is I've created a simulator that shows this, but essentially the message payload, a lot of the characteristics are exactly the same. I've also tried to have some fun with some plant names, as I can't show you our plants, but I can take advantage of some of our friends from different regions here in the audience. So in this case, we do have our partner environment where they're going to have their historian, and they're going to be publishing telemetry data to our event hub. They're going to be doing this through AMQP. We've got different sets of tag groups, we'll call them. So we're talking about 1-minute data, 15-minute data, 60-minute data, and what we call raw data. Raw data is basically when we have a change of state. So as soon as something changes that we need to know about, it would be published to us in near real time. So you can think of that as an alarm. If we start to have a piece of equipment that's starting to trip, we can publish that right away to us. Once it's in Event Hub, we're going to have Stream Analytics attached to that. And this is a very simple scenario where we just want to grab all of those messages, that message payload, and route it to a service bus topic, which we have BizTalk listening on. So in this case, this is BizTalk 2013. We are using the SB messaging adapter. Now, all of this data is coming in using JSON, and our historian, back to that whole vintage comment, it wants to receive this data in a CSV format. So we're going to use BizTalk to do that transformation between JSON and CSV. So what I'm going to do now is I'm just going to start my publisher here. Once it gets fired up, it's going to publish an event every second. Sorry, it was just because I had zoomed in. So you can see this bar is moving here, and we're publishing. Basically, it's 10 reads every second. Now, because I have some other demos and I don't want to spend time on a file adapter scenario, I'm just going to let that one ride. And as I said, the other demos will build on top of that. But just to give you some insight, here is some of that code from the simulator. I'm going to create a very simple event hub connection. I'm going to instantiate a message where we kind of have this header details type scenario. Next, I'm going to, for the interest of the demo, I'm going to use some randomized tag values, right? So I just have a method here that's going to randomize data for a specific tag. Now the reason why I have this toString is in the real world, actually, not all data is actually a numeric value or a float. In the example of alarms, it actually can be text. So we have to deal with that in Stream Analytics on how we deal with that sort of data. But also notice the tag name here. So this is a very unuser-friendly, very technical tag name. And down later in the demo, I'm going to show you how we can use user-friendly tag names on our actual dashboards to represent that. Next, I want to just serialize this C# object, this message, and put it on our event hub using the async method. Here's what the message shape looks like. Nothing overly complex, but really tag name, tag or timestamp, a value, and a quality. From sorry, it was JSON. Oh yeah, no, that was something left over from the POC. So we excluded that in prod. So here, in order to avoid some flipping back and forth, I just take some screenshots of the Stream Analytics. And in this case, I just want to show the input. So you define an input, you define an output, and then you have a query that runs in between. So here I'm saying I want a data stream. It's going to be an event hub. And then what I am able to do is look into my subscription, select my namespace, provide my policy, my key, and now that'll be able to wire up. So my Stream Analytics query will be able to tap into this event hub. On the flip side, here's my output. It's a service bus topic. And similarly, I can go ahead, select my subscription, select my namespace, provide my connectivity details, and now Stream Analytics will be able to publish to that topic. So here's the hello world of Stream Analytics, and all I'm doing here is I want to say, I want everything from my event hub and put it into my topic. So this is just taking the raw data, and basically as soon as it gets inserted into event hubs, it's going to get pulled and delivered to the topic. From a BizTalk perspective, we're going to be attaching to a service bus topic. We're using a send port subscription in this model. We're going to go ahead and convert that JSON to XML because XML is first-class citizen of BizTalk. Then we're going to convert that XML into CSV because that's what our historian wants, and put it in the historian file collector. And here is our output. I've de-identified some of it as we had some real tags within our production. I took this from out of our production system. So nothing overly exciting there, but as I mentioned, the good stuff is coming. So the next part of this is real-time visualizations. And what's interesting about this is we have kind of our existing path, our existing solution, and now we're able to build on top of it. So this goes to that flexibility, velocity, and the ability to add value incrementally. So now what we're going to do is we're going to attach Power BI to our Stream Analytics query. And now we can take that same data that was being published to a topic and sent down on-prem, and we can now route that to Power BI. Yeah, I did get challenged by MFA. So in case you want to know if Azure MFA works when you travel abroad, there you go. This is a free demo for you. So here's my real-time dashboard. Now we can see if you see a drop, it's related to my simulator. It was taken offline for that period of time. But we can see that this was refreshed a few seconds ago. And what I've got is now these user-friendly plant names that I was talking about. So Calgary, Phoenix, Redmond. If I go over to Scandinavia, we'll see Bergen, Norway, where our friend Tord lives, Stockholm. And we've got West Europe plants, and we also have APAC plants as well. Now, if we dive into one of these, we can actually see the data as it's streaming across, and we can see that it's up to date. Now, this is back in Calgary time, so in case you're wondering why it's 11:53, that is why. If we go back to my main dashboard, now we can take it, I guess, double click on this and get a little bit more detail. Now, it is kind of cool though to watch the lines update automatically as the data is flowing through Stream Analytics and onto Power BI, but it doesn't really give you any insight. It doesn't give you actionable insight. You can't manage a plant by going, oh, it's at 100, that's great. You know, you need to basically be able to measure it against something. So what I've got here is I've been able to take advantage of some of the reference data. So I've attached lat-long coordinates to these plants, and now I can display that on a map. So I can drill down into Calgary, and I can see what its basically curve looks like. And now I can also set a line. Now this black line here represents the expected output. And now what I can actually do is measure that against what I'm expecting. So my plant output is currently 70.90, whereas my expected output is 76. So now that's something that I can act upon. I can actually look at a plant manager saying, hey, I'm supposed to be at this value and I'm here. So why am I doing that? Now I can start to focus in on why that piece of equipment isn't actually performing the way it's expected, or the plant output isn't what we expect. We can drill down into another couple locations. We'll see what Mikael and his plant is doing in Stockholm, and we'll see that he's missing his target here. So no bonus for Mikael this quarter. But once again, it's that ability to get some real insight into what's happening in your plant. Now, unfortunately, I had a couple other visualizations for you that leverage some from the gallery, but those are no longer working this morning. So, but there is other opportunities to use these custom visualizations from the public. Maybe they're not quite ready for prime time, but we have used them in the past, and they have worked relatively well for us. So from a Stream Analytics perspective, what we have here is we're going to have two inputs. We're going to leverage the existing Event Hub input. So we can attach multiple consumer groups against that, and they can manage that stream independently. They can read off of it independent from one another. We can also add reference data from blob storage. And then what we can do is query across streams in real time. What this allows us to do is we can add a CSV file up into blob storage. And in this case, it's very simple, but it's really powerful, where we can add our tag name, a lat value, a long value, plant name, and our expected value. And this is what now allows us the data to flow through with that technical tag name, and we can represent it as Redmond or Calgary. This is also where we can load our expected value. So now in Power BI, we can plot that, and we can see our real-time value against our expected values and actually develop some KPIs. Now in this case, it's static data, but there are mechanisms inside of Stream Analytics where if you're putting this in the right folder structure, so say date, then time, what it'll do is it'll actually pick up the latest value, the latest file, and actually load that. So if you have values that are relatively back, you can feed those continuously as well. From an output perspective, here's where we're going to define our Power BI output. And in this case, I'll sign in. This is the purpose of the demo. I'm using my account. I wouldn't recommend that for production, for issues such as MFA. And I can choose my workspace, my table name, and my data set name. Here's the Stream Analytics query. Now, what's interesting about Stream Analytics, it can work in almost like a pipeline. And in this case, we can create what I would like to equate to a temp table. So we're going to call this tag read aggregation. And we can perform a query and store the result in that temp table. Then we can use that later down in our process, where we can query against that temp table. So in this case, what I need to do, because I have that JSON message with an array of JSON objects, I need to break that apart. And I can do that using this cross-applied get element statement. And then what I'm able to do is to create a tumbling window. So my simulator's publishing data every second, but now what I can do is aggregate that against this tumbling window, and basically apply an average against it. So as we saw before, it was a string, so I needed to do a cast against it, but then I'm going to do an average. So it's going to take all of those reads over the 60 seconds and give me one value. So when we, per plant, so that when that goes to Power BI, it's already been averaged.
How long will you have data in that temp table?
Well, no, so it's for the execution of this window, right? That's all it is for the execution of this window. And then basically that stream, completes, and then the new stream picks up. And then what I'm able to do is from my secondary query is I can now query from that temp table, what I call a temp table, and I can actually join it with my reference data. So in both of my data streams, I have something called a tag name. So really that's my key that links these two streams together. And then what I can do is I can add these additional fields from my reference data like lat, long, plant name, and expected value. And the end result is when I go into Power BI, is I'm going to see this consolidated data set. And I can go ahead and drag visualizations from here and then start to apply the different fields that I'm interested in. So it is kind of a nice way to stitch this data together to really enrich the data set that was coming in live. Because in this case, our partner wouldn't have our user-friendly names, it wouldn't necessarily be interested or care about our lat long data, things like that. So the next demo I want to talk to you about is this absence of event. So it's the idea of, when things are going well, that's great, but what happens when you have a device that stops producing telemetry? You want to know about that sooner than later. So once again, building on top of our existing solution, still have the same event hub, we have Stream Analytics with the same query, we're still delivering to Power BI, but now what we can do is basically look for these exception processes, and in this case what I'm doing is I'm going to take that message, drop it on a service bus topic, Logic Apps will pick it up, it's going to, in this case, call an Azure function to do a little bit of cleanup on the message itself, and then I'm going to call my custom API app that's going to talk to ServiceNow, and then I'm going to inform my operations staff that I've gone ahead, detected this event, created a ticket inside of ServiceNow that someone needs to respond to, and then send out some messages. So what I'm going to do here is I'll stop that data stream, and I'm going to start my missing events data stream. So what happens here is I basically have a tag that's missing from my data set. And in Stream Analytics, I'm going to actually detect that. So while that's running, I'm going to log into the Azure portal. Going to jump into my Logic Apps. And my first shape is this green shape, which is my service bus connector. And what I'm doing is I'm attaching to a topic called Heartbeat Topic, and there's a subscription called All. So basically, any messages that come into that topic. Next, what I'm going to do is I'm going to take that message body, and I'm going to send it to my Azure function. And in this case, I do need to wrap it around some JSON because the input is expecting that. And really, this is just my message body coming from the service bus topic. The next three cards are my service bus connectors. And so just in case you're wondering, that's the sound of me getting a text indicating that there's a missing tag. So let me just shut that down so we don't... So within here, I'm going to go ahead and call my ServiceNow API. And I need to make 3 calls. And the reason is that there's some reference data that I need to provide when I go ahead to create that incident. So what I'm doing here is I'm getting my user ID from ServiceNow. I then need to know what group I want to assign this to. So I need to get that ID. And then what I'm able to do when I go ahead and post is I can use the output from those previous calls, in this case these sys IDs, as part of my post message when I actually go ahead and call ServiceNow. I can also use some of the outputs from my Azure function in terms of the tag name, the missing time, and the overall body. And then I can go ahead and send emails to myself letting me know that I have a missing tag, and I'm going to go ahead and also send a Twilio message. Let's quickly jump into the Azure function. And the reason why I need to call this Azure function is when Stream Analytics is publishing to a Service Bus topic, it's going to include some serialization data that I'm not really interested in. It kind of corrupts my true JSON message. So all I want to do is to really strip that out. So to give you an example of what that message looks like, it's really here. I get this ugly string HTTP schema serialization tag. And really what I want to do is I want to be able to strip that out. So there's a nice facility, a testing facility inside of Azure Functions that'll actually remove that and give me my clean message that I'm interested in, which is my true JSON message indicating 0 heartbeats were processed for that tag. This was the timestamp. And yeah, so that's how it's going to go ahead and clean that out. And really what I'm doing here is I'm going to go ahead and just do look for the first index of my curly bracket and remove everything before it before I output that back to the logic app. So let's go into ServiceNow, and we can just make sure that that incident was created. And in this case, this is a free instance of ServiceNow. So even within your organization, if you're a ServiceNow customer, you can go ahead and create your own sandbox for free. And you can go ahead and try all this stuff out on your own if you wish, without having to deal with any sort of red tape. So here's the event that was just created. So this was at 2:08, so this is Pacific time. So that was 3 minutes ago. And we can see that, yes, it was created by myself. And that plant operations group that I talked about, that's been lined up because I passed the right data in. And then I can also see that here's my missing tag, here's the timestamp for that missing value. This is always a dangerous thing, but here's the email that would have gone out, and here's the indicating that there's a tag that's missing, and the result from my ServiceNow API call. And now I have this ticket number that's included as well. Here's my Stream Analytics query, where I'm able to look for this particular process type. And really, if there's none that exist, 0 is going to be returned. And I'm able to store it in this temp table once again. I'm sure the Stream Analytics team won't like me for using that terminology, but it's the best way to describe it. And then what I'm able to do is in my secondary query, I can go ahead and say, I want to know if there's a tag that exists where tag processed is 0. And then I'm able to insert that missing tag name that I was looking for. Here's the logic app we went through. Here's the Azure function. And because you can't all see my phone, here's the result of the text message from the Twilio account. I have the ticket number and the tag included. So monitoring, I'll go through this relatively quickly. This is a real-life scenario for us. So you think if you've got all these different cloud services, and how do you perform some monitoring around it? We are a long-time BizTalk 360 customer, and we've been able to use the Web Endpoint Monitor. Now, Saravana took a little bit of wind out of my sail yesterday because I no longer need to include some of this. But with the previous version, in version 8, with the Web Endpoint Monitoring, it can only perform gets. And in this case, I need to actually post something to the Event Hub. So I'm going to use Azure API Management, which we already use. I wouldn't buy API Management just for this purpose, but we already use it, so it was easy to do. So I can send a get to API Management. It'll actually take that get, turn it into a post, include message payload, put it on the Azure Event Hub, and then I can have it route through all of my steps. And then on the back end, what we're going to do is we're going to use BizTalk 360 process monitoring to actually ensure that we're kind of doing the complete loop. We know we're constantly pushing data, so now what we can say is every 15 minutes we expect so many of these heartbeats to be processed, and if we don't get that number, then we're going to send off a note to our integration team. So here's the web endpoint monitoring, which we saw yesterday. Here's the Azure API policy. And I had to gray out some of this stuff because it is production, but here's our HTTP, our URL for our Event Hub. I need to provide an auth token, and here it is here. And then I can provide, in this case, it's a static message body, which is okay. Here I'm setting my HTTP method to be a post. And basically, that'll take the get in and create a post and put it on the Event Hub. Here's, once again, a very simple Stream Analytics query. In this case, all we want to know is, the process type is heartbeats. And when we find any of those, we're going to take it from the Event Hub and put it into our heartbeat topic, which BizTalk can pick up using the SB messaging adapter. And then on the flip side, on the last end of the tail end of this is where we'll have our process monitoring in BizTalk 360. In this case, we're looking for 6 heartbeats every 15 minutes. And if we don't get at least 6, then we're going to start to send out notifications. So quickly, lessons learned. I think it's important to drive adoption through POCs, proof of concepts. Now, I know this can be a bit of a dirty word, but I think with cloud technology and where it's at now, I think there's no better time than to do this, where it's like, hey, I have an idea. I want to try this out. I can do a lot of this stuff in hours or days, and the investment to the organization is extremely small. No longer are you asking for someone to provision multiple servers like Stephen Thomas mentioned. Hey, I can try this in the cloud. I can pay for exactly what I use, and when I'm not using it, I can turn it off. So we've really adopted this model in terms of test and learn, and actually, let's experiment. Let's try this. And if it doesn't work, we'll shut it down early and we'll move on. Decision makers typically like the option to say no. Give them that opportunity. And I think this really, is part of the whole POC, where it's kind of like, hey, if you don't think this is the right idea, let's do a short-term engagement. Let's see if it works. If it doesn't work, shut it down, no problem. But if it does work, then we're going to continue moving forward with this. Frame benefits holistically. When we were working with this partner, there were some concerns. Oh, this is cloud, this is security. Is this the right thing for us? Well, we went to say, hey, there's some benefits in this. We're now decoupled. We no longer have a VPN connection tying your data center to my data center. You don't have to worry about what I'm doing. We don't have to worry about patching. We don't have to worry about outages, right? That's Microsoft's responsibility. You publish to that endpoint, I'll pick up from it, and now we've got this clear delineation of responsibilities. Involve security early, bit of a miss on our side. We had done a bunch of things in Azure in a previous project, so I kind of felt that we had the green light to move forward with this, and they were a little bit surprised, and we probably should have included them early, so that was the lessons learned. Write ASA, Azure Stream Analytics queries defensively to avoid job failures. Back to some of the reasons why I have that casting in there, and so it's one of those things where you might want to have like a clean reads and a dirty reads, where you actually make sure that your data is clean by doing some different queries and actually testing for certain conditions, and then using those temp tables as I described. Because what I've found is that Stream Analytics, when the jobs fail, they can fail hard. And when they fail hard, they stop. Which means you're not losing data, it's still in your Event Hub, and basically when you start it back up, you can choose, I want to start it based upon the last time the job stopped. But if it fails hard, that means your data is not flowing. So you want to be careful around that. Don't tie Power BI accounts to a user. During the earlier stages, I had it tied to my account. We rolled out MFA, it broke that stream. So I think there's different strategies around this. We chose to create service accounts for some of these specific interface-related Power BI reports. Decouple your data collection from your analytic streams. And this is kind of related to the jobs failing hard, but if your core requirement is data collection, you don't want something going wrong in your analytics stream to stop the job that prevents you from delivering your data. So I think that's important as well. You'll pay more for it, but it's only like 27 bucks Canadian for a second stream per month. So for us, it was worth it. Leverage Event Hub's replay capabilities. We talked a little bit about this yesterday. It helped us big time in some of our testing, where we could actually kind of, choose when we wanted Stream Analytics to pick up the data again. So what we found is, we ran into some issues in our historian, but then we're like, oh, how are we going to reproduce that? Well, it's like, okay, what was the time frame? So we stop our Stream Analytics job, choose when we want to start it previous, right around the time of the issues, and then went forward again. Things that would be very difficult or cumbersome to do in BizTalk now is like very simple in Event Hub. Power BI can only be configured after you have data, especially with this streaming stuff, the real-time stuff. Data has to land into Power BI for Power BI to understand kind of the schema or the shape of the data. So you have to be prepared for that. So when you go live, you're going to go live with an empty dashboard. But if you've gone through that process in say, a previous environment, you can quickly replicate that in Power BI. For us, we are BizTalk 2013. We did run into the ACS issue. So that's just something to be aware of. You need to create your namespace with ACS in mind. We'll be going to 2016 as soon as it's RTMs, so then we can get away from that. Don't forget about monitoring. And then my last slide is what's next. For us, we're really focused on plant modernization. We, in this kind of current economy, where oil prices are down and you're in a resource-rich environment, we really need flexibility. So as we invest or divest in certain plants and fuel types, we need flexible models, pricing models that allow us to adjust accordingly. We can't do a lot of upfront, large-scale capital investment. We like cloud for that reason, where we can turn it on and off as required. And we want to reduce our dependency on expensive proprietary software. A lot of these capabilities like real-time analytics, preemptive maintenance, these are now scenarios that are commodities in the cloud. We want to reduce our dependency on expensive long-term contracts. We are really excited about the OPC UA, the work that Microsoft and Clemens has been doing. And what that really allows us to do is to start to inject these cloud endpoints down in our plants. Now, we won't get to the very low-level plant operations networks, but what we can do is we can start to inject it around our historians. And maybe we start to publish differently than we do today. So everywhere there's an OPC UA here, what that represents in the future is the ability to publish to the event hubs, right? So Dan is smiling, I can see it from here. But this really provides an opportunity for us when we're dealing with 3 continents of data. Now we can use the cloud to bring that all together. And we're going to continue to work out the advanced analytics capabilities. So machine learning is on our list. There's some real need there. You think of running tens and tens and tens of plants. There's a lot of opportunities to streamline your maintenance activities. So I'm cutting into your break, so I'm going to leave it at that. But if you have any questions, feel free to have a chat. Happy to dive into any more of these details as well. So thank you.